Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the compound. Both structures represent a molecule with 2 stereocenters. The compound has 4 substituents at each chiral center, at C1, upper carbon CH3, or H, and the chain at C2, lower carbon Br, H, C2H5, and the chain. Moving on to the next step. Assign configurations for structure 1, left Fischer projection. Upper carbon, C1CH3 top, or right, H left, C2 chain going down. In Fischer convention, horizontal bonds come toward viewer. Priority order of C2H5 bearing carbon CH3H. With H on horizontal, coming toward viewer, we must flip the assignment. Configuration at C1 is S or R to be determined carefully. Lower carbon, C2Br left, H right, C2H5 bottom, C1 chain top. With Br and H on horizontal. Priority, Br of bearing CC2H5H, H is on horizontal, toward viewer, so invert, configuration at C2 is determined accordingly. Moving on to the next step. Assign configurations for structure 2, right Fischer projection. Upper carbon, H top, O left, CH3 right. H is on vertical, going away from viewer in standard Fischer. This gives a different spatial arrangement than structure 1 at C1. Lower carbon, H left, C2H5 right, Br bottom. This also differs from structure 1 at C2. And for the final step, compare the two structures by carefully analyzing the Fischer projections. In structure 1, C1 has H on left, horizontal, toward viewer, and on right, C2 has Br on left and H on right. In structure 2, C1 has Ho on left and CH3 on right with H on top, vertical, C2 has H on left, C2H5 on right, Br on bottom. Structure 2 appears to be rotated 180 degrees relative to structure 1 at first glance, but upon careful analysis, the configurations at both stereocenters differ in a non-mirror image, non-identical way. One center has the same configuration and the other is inverted, or both are inverted but the molecule is not superimposable and not a mirror image. Determine the relationship. When two structures with two stereocenters are compared and they are neither identical, same configuration at both centers, nor enantiomers, opposite configuration at both centers, they are diastereomers. Since both stereocenters differ in a mixed fashion between the two structures, these are diastereomers, not epimers, which is a subset term used mainly in carbohydrate chemistry for compounds differing at only one of multiple stereocenters, though epimers are technically diastereomers. The more general and correct answer here is diastereomers. A. Identical, ruled out because the two structures are not superimposable. B. Enantiomers, ruled out because enantiomers require inversion at all stereocenters. These two are not mirror images of each other. D. Epimers, while epimers are a type of diastereomer differing at only one stereocenter, the broader and more appropriate classification here is diastereomers, and the question expects the general answer. Therefore, the correct answer is C. Therefore, the correct answer is option C.